Okay, this is a really perplexing question on angles in circles. And at first look, you probably would think that this is unsolvable because you don't know either arc in the circle. All you know is this one angle, exterior angle of your circle. So I first want to recognize that I'm actually asking for, this question is asking for, by the way I named this arc with 2 letters, it's asking for the measure of arc EF, the minor arc. So that's going to have to be, just so we're all looking at the same thing, it's going to have to be this arc, because the other one is a major arc. It's more than halfway around the circle. The reason I know that to be true, I'm not really just assuming off of the picture. If this was more than half the circle, then these 2 lines, tangent lines, would not intersect at this point. So exactly halfway across the circle would give you 2 tangent lines that are parallel. Maybe you can picture that. And then if those points were actually a little further on this side, then the lines would be intersecting over there. So that's what I'm trying to find, and I'm going to go ahead and label that X to indicate that's my unknown. So the next thought is like, okay, let's go with our exterior angle formula. We have an exterior angle formula that I think can help us out here. So my general exterior angle formula is angle equals arc minus arc divided by 2. Sometimes I like to say big arc minus little arc divided by 2, but you're subtracting 2 arcs. So the question is, what do I know? Well, I know that the angle is 39 degrees, so they gave me that piece of information. So the angle is 39, so I'm seeing this as a working backwards question. Now, this would be great if I knew one of the 2 arcs, but the problem is I don't know either. So it looks like I have the smaller arc is my X. My little arc is the one that I've highlighted in red. So the big arc, let's go ahead and find that one and say, what do we know about that arc? And maybe you're seeing hopefully you're seeing that is the rest of the circle. If it helps, you can certainly extend lines here. So sometimes I like to extend my tangent lines so I can really see that that's the point that's dividing the circle into those 2 pieces. So it's the rest of the circle. Okay, so that gives me a couple ideas. One option is, and we definitely have options here. One option is to call this Y, just to indicate, or pick a different letter, indicate that it's different than arc X and it's another unknown. And you can certainly do that. The other thing that you can do, and I'm going to kind of force you to think a little bit more, because I think it's going to be easier if we keep it in the same variable, is how could I name that arc in terms of X? So maybe let's just give ourselves a number. What if X was 100 degrees? Well, if this was 100 degrees, how would you find this arc? Don't tell me the answer. Tell me how you'd find it. Yep, you would do 360 minus 100. So what if this were 150? Same thing, 360 minus 150. So couldn't we name this arc then 360 minus X? Whatever X is, I would subtract from 360 to get me the rest of that circle. So that means that I can actually put that in for my big arc here, 360 minus X. And now I actually have an equation in terms of one variable. Magic, right? So now I can go ahead and solve. So let's go ahead and do some simplification here. 39 equals 360 minus X minus another X is minus 2X, all divided by 2. And then in this case, because 360 and 2 are both divisible by 2, you could just divide both of those by 2 and get 180 minus X. Or the way I did the last one, so just to be consistent, I'll just go ahead and do it the same way. I multiplied by 2 on both sides is kind of my general strategy here. So if I do the same thing, multiply by 2, times 2 divided by 2, cancels each other out, and then I'm left with, on the left side, 2 times 39, which I believe is 78, equals 360 minus 2x. And then your version of what you want to do from here, you could subtract 360. I'm going to add 2x and subtract 78 to keep things positive. So 2x equals 360 minus 78, which is 282. And then divide by 2. And that's giving me 141 degrees. Because I labeled my actual arc I'm looking for as X right here, that is my answer. And I'm done. Okay, so that's one way to do it. Now, I want to just give you a quick thought based on our initial thing that we said, and some people have been very successful doing this problem this way. If you had gone with Y here and called this arc Y, let's just take a look at that for a second and see what happens. So in my equation that I wrote, I would have ended up with the angle 39 equals y, because y is my big arc now, minus x divided by 2. Okay, so that's a rewrite of what I have right here. But now instead of using the 360 minus x, I'm just using y. Now I would have looked at that and I would have said, okay, well, I can't solve one equation for two variables at the same time. So what else do I know in this situation? What else do I know about x and y? I would have had to come up with a second equation. And at that point, you probably would have looked at the circle and said, well, I actually know that x plus y equals, oops, not 180, equals 360 because that is all the way around the circle. Look at what you have. What do we have right here? Yeah, hopefully you're seeing that's a system of equations, not something new or something new or different to us, just we haven't done them with circles. So we could certainly solve for x or y. I'd probably solve the second equation for x if I do that, or sorry, for y. Y is 360 minus x. If I do that, and then I've got y is equal to 360 minus x, if I make a substitution right there, guess what we end up with? Same thing we had right here. So algebra would be very similar. There's obviously other ways to solve the system in terms of substituting into a different place, but that's kind of the idea. Okay, so that gives you a couple ways to think through this problem. The other option, oh, I got to show you one more. Sorry, this is just too fun to skip. So if we find the center of the circle and we draw out, there's a theorem that I've referenced that if we have a radius, or it's easier to see if you have a diameter, because then you can see that the diameter and the tangent make an inscribed angle here. The inscribed angle is half the arc, which is 180 degrees. So there is a theorem that says, for sure, no guessing, this angle right here is going to be 90 degrees, and this is also going to be 90 degrees. So I inserted two radii into my picture. And what I've done is I've created a quadrilateral. If you're going to name this quadrilateral, you might be noticing that these two radii are congruent, and it appears that these lines are congruent, and I'm going to actually propose that they are, the two tangent segments there. So we actually have a kite. Not that you need to know that. All you really need to know is that we've got one angle missing in our quadrilateral, and the four angles in a quadrilateral always add up to 360 degrees. So just for fun, 90, 90, and 39, add them up. And that gives me 219. 360 minus 219. Any guesses? Bingo, 141. Okay, hopefully that was a little bit exciting. I love it when there's different ways to do problems. So you don't really need to know all three, but hopefully one of those clicked with you.